Hi, thanks. Welcome everyone to Spark Summit Europe. This is our second event in Europe, and I'm super excited to be here and to see the conference sold out. So as Andy said, I'm going to talk about simplifying big data with Apache Spark 2.0, which is the major release of Spark that came out this summer. So let's get started. So first of all, I wanted to talk a little bit about just what's happened in the open source project this year. And 2016 has been a really great year for Apache Spark in terms of growth. We see basically the same rate of growth that we've been seeing for the past 5 years in terms of new users and continuing, increasing adoption. So just some numbers on that side. One number that I look at often is the number of meetup members and Spark meetups worldwide. We held an in-person meetup here yesterday as well, and there are tons of groups around, around the world. And this number grew by almost a factor of 4 from 2015, from 66,000 to over 200,000 members. So that's a really cool thing to see about the growth of the community. Second number is the number of developers contributing to Apache Spark. So about a year ago, the total number of contributors was around 600, and this year we've crossed 1,000. And then finally, another number that's gone up, a different type of number though, is the version number. So we hit sort of this milestone of Apache Spark 2.0 with the release this summer. So I'm going to talk more in here about what's kind of new in the new version, but also how this came to be and basically what we think is needed to simplify big data processing that we're trying to do through the Spark project. So what is Spark 2.0? So first of all, of course, it's a major version number, which means it's a chance to change APIs and things like that. But we care a ton about backwards compatibility in the project, and so we've tried to keep everything as compatible as possible with 1.x so that it's easy to switch to. And in some places, we simplify the API or reduce the dependencies of the project. That's why it's a new major version number. And this release contains over 2,000 patches from nearly 300 contributors. And we're also seeing pretty fast adoption of it, at least at Databricks, where I am, which is a cloud service we can measure, and basically 40% of our workload is now on Spark 2.0. So just to explain what's in it and how it simplifies big data, I want to first talk about what's hard about big data processing. And basically, in talking with users throughout the lifetime of the project, we saw two things that make big data processing pretty hard, no matter what tools you do it with. The first is that big data processing usually requires a complex combination of different processing tasks, storage systems, and processing modes like batch or streaming. These applications are rarely simple. You rarely have clean data that you just pass into some algorithm and get an answer from. Instead, most of your work is things like ETL, just munging the data, cleaning it up, maybe joining it against other sources to extract and transform and load, aggregation, and then machine learning, and so on. So it's basically a sequence of these steps. And the second thing that's complex is, apart from having to do these different things, there's often a trade-off between productivity and performance. The tools where you can write, what you want to do in a couple lines of code are often not the most performant ones. And of course, performance matters for big data in particular because you need to iterate quickly to get back an answer quickly. So that's kind of the second issue that we've seen. So Apache Spark's approach to this problem is kind of twofold. First of all, from the beginning of the project, we decided to create this kind of unified engine that could express entire workflows. These different steps I talked about before, they're just all function calls you can hook together to build a whole workflow. And that makes it much easier to build these large workflows. And we also designed it to easily hook in with different processing libraries and storage so that the differences between, say, two storage systems are kind of hidden away from you behind the same interface. It looks to you like a Spark SQL table or like an RDD. And then the second thing we have in the project is these high-level APIs that leave a lot of room for the engine to optimize. So we try to make sure that the engine moves in this direction so that we can do a lot of stuff under the hood, as the project develops. So this started with RDDs, which were this functional API that, tells you what code to run, but doesn't say how to schedule the computation on the cluster, and it allows for things like pipelining different functions. Then DataFrames have a even kind of more expressive representation of what you're doing, which I'll talk about, which allows more optimizations. And in the machine learning side, things like machine learning pipelines are also very declarative and leave a lot of room to optimize. Okay, so what's new in 2.0? There are quite a few, new features across the board because, as I said, it's a pretty big release. And in this talk, I'm just going to focus on some of the highlights, which are the structured API improvements, really stabilizing the DataFrame, Dataset, and SQL APIs, whole stage code generation, which is one of these optimizations I talked about with productivity and performance, and finally, structured streaming, which is still an alpha component, but we think it's an exciting way to simplify building streaming applications. All right, so let me talk about the structured APIs. So if you look back at the original Spark API, and of course it's still a very widely used API, it's this idea of RDDs, where you have these distributed collections of data and you apply Java functions on them. So you just run any Java function you want, and the data model is Java objects. They're just floating around there. Anything you can define as a class in Java can sit inside your RDD. And you can take things like here, take an RDD of strings and turn it into an RDD of, say, points, and point is some class you defined with all kinds of crazy features in there. Now, this API has kind of some pros and cons. So the biggest benefit, the reason I think people really jump to this, is because it lets you build complex applications. You can organize your application using functions, classes, and types into a large program, and you get all these abstractions that are in programming languages when structuring your big data pipeline. But there are also some disadvantages. Because everything is Java objects and Java functions running on them, it's really hard to optimize it to do anything non-trivial with it. In particular, when we try to store these things in memory, they're just Java objects. They can have subclasses, they can have nested graphs of pointers to other stuff. It's really hard to have an efficient in-memory format other than letting the JVM do it. And also, if you have a bunch of these operators, it's hard to look inside them and see what they're doing and do optimization across them. Like, for example, push a filter into your data source because you're only pulling out records that pass a given predicate. So these are kind of the trade-offs. So the structured APIs are a new set of APIs that have been coming together the past 2 years. They are highly, they integrate very well with the RDD ones, but they allow you to do more sophisticated optimizations for some types of processing. So these are for data with a fixed schema. We have a table-like data model, which is not just arbitrary Java objects, but it's still pretty expressive. And using the schema, we optimize storage. We can do stuff like columnar storage or compression of the data. And also, most of the operators you pass to these APIs take in expressions in a DSL or domain-specific language that describes what you're doing with the data in a way that the engine can understand more easily than being given a Java function. So that allows more optimization. And there are 3 of these APIs. They all run over the same kind of code base underneath. These are DataFrames, which are untyped, datasets, which are typed kind of interface on top of them, and of course SQL. So just to show what these APIs do and why it's interesting in terms of productivity and performance, I'll show a little example and the types of optimizations that can happen. So this is a little example using the DataFrame API. We basically read some data, in this case from JSON, some log events, and then we do some operations on them, like maybe join them with a table of users and group by 2 fields and average. And then we pull out, okay, we only want the ones where the status equals error, and that's what we want to get. So these operations in there, the group by and average and stuff, look sort of similar to what I had before with the map in the RDD example, except they don't take Java functions. They actually take some field names or expressions involving field names, such as the where expression in there, which the engine can parse and then can optimize. So what actually happens when you get this is Spark represents it internally as a query plan, as kind of a tree of operators, and it can do these kind of non-trivial changes to optimize the plan. So for example, in this case, you see we're filtering out error only the error status events at the end. But in the optimized plan, we actually push the filter to the top right after we scan the logs, because there's no point keeping the other stuff. So this is the kind of thing that would be very hard to do in the RDD API, because we'd have to look into your Java functions and see what they do. And it's hard to make that in a non-brittle fashion. And then finally, given this plan of operators, Spark can actually optimize across all of them when it's running the query as well. So in particular, with some of the new features in 2.0, we actually generate code that fuses together many operators. So in this case, as you scan through logs, we do the filter and the group by and the average just in the same pass through the data, which is something, so it lets you still build your computation using these separate operators, but it lets you get high performance at the end. And there's many other cool features as well. For example, if you had something like a Parquet data source which has indexing built in, we could actually push that filter I talked about into the scan itself. So this is the kind of stuff we do in the structured APIs. So these have been around for a while. What's new with them in 2.0? There are really kind of two things. The first is kind of cleaning up and stabilizing the API. And the biggest change there is merging the DataFrame and Dataset classes. So when we introduced these, Dataset had to be a different class because we couldn't break backwards compatibility with Spark 1.x. And we didn't want to just mess up people's code. But in 2.0, DataFrame is now just a special type of dataset of raw objects. And it's much easier to work between these things. You can basically take a data frame and cast it to something with Java objects in it and suddenly get types. So that's one of the reasons we decided to bump up the version number to implement this change. And then under the hood, a major thing that came out, as I mentioned before, is this whole stage code generation. So being able to fuse multiple operators and generate efficient code for your query. And we also generate code to read from Parquet. So this has led to some pretty big speedups. Both, these are some simple benchmarks, but there are quite a few users that report the same speedups of close to a factor of 10 for basic computation and for reading from Parquet. And one final thing I wanted to mention about performance is about Spark is something really cool that came out basically 2 months ago, which is Facebook's use case of Apache Spark. So, I talked a lot about low latency kind of in-memory stuff, but this use case is actually some of the largest batch jobs that Facebook was doing using Hive, which is, a batch processing system optimized for that. And they were able to port these to Spark SQL and actually make these batch jobs on faster by a factor of 3 or 4 using Spark SQL. It's really cool to see this in basically some of the largest jobs there. And this is without the whole stage code gen stuff in 2.0. So hopefully that can add even more benefit to this type of workload. And there's going to be a speaker, Satil from Facebook, later today who will give a talk about this. So that's kind of an overview of how the APIs are evolving and how we think this will simplify big data in kind of the batch and interactive setting. The final thing I want to talk about is going beyond batch and interactive, designing these types of higher level APIs for streaming. And this is what's happening in the structured streaming project that's kind of alpha in 2.0. Okay. So first of all, what's difficult about using streaming? We actually spent quite a bit of time at the beginning of this year talking to users of streaming systems and trying to figure out, what is hard with them in the systems they're currently using. And we basically saw two things. The first thing is that streaming systems tend to have very complex semantics. It's, distributed systems, just to begin with, are kind of hard to think about. But now, if they're streaming and if you have to worry about passing messages between nodes and what order they get there and stuff, it just becomes more complicated. So one question is like, what results can a streaming program even give? In a lot of the widely used streaming systems, it's actually very hard to precisely say what they can give, because if some nodes are ahead or behind each other, you only see the results that have made it through the system so far. So you might see, for example, a result for like an event that happened at 5 o'clock, and even though you got the previous data from 4 o'clock in the system, it hasn't yet made it out the other end. that's a kind of problem that happens. And the second thing is what happens if a node runs slowly or if one of them fails. So, for example, if you're collecting tweets and there are lots of tweets in one country, such as Japan, and the node that has that key is running slowly, that means you'll be behind on the tweet stream from Japan, and that makes it harder to do analysis of the whole tweets around the world. So this is one of the things, it's just things you have to worry about when doing these. The second thing that's complicated is basically integrating streaming into a complete application. When we talked with people, pretty much nobody just wanted to do streaming on its own. Instead, streaming lives as part of a bigger application on real-time data. For example, a really common thing is you want to serve real-time queries. Say you have users that see some kind of dashboard or that can drill into data in real time, and you want to serve them from the result of a stream. So now to do that, usually you have to set up a streaming system, then set up some kind of storage and once in a while update the data and then set up some kind of interactive query system. It's pretty complicated to set them up, and there aren't too many guarantees about like, oh, if the streaming system is in the process of updating the data, what do the queries, what results will they give, and so on. And a similar thing that happens even without kind of the real-time query aspect is just if you have a larger data pipeline and some of your steps are streaming and some of them are batch. The question now is, how do you make sure the streaming system gives the same result as batch jobs? It's bad if, for example, a user logs in and sees their bill in the live dashboard as being one thing, and then the bill they receive by email at the end of the month is different. All right. So what are we doing to address this? So structured streaming is a high-level streaming API based on data frames and data sets, and it's meant specifically to have simple semantics and to integrate into complex applications. So it has the same semantics and results as batch jobs. If you run something as a Spark batch job today, this will give you the same result, just do it on increasing sort of amounts of data as new data arrives. So you don't need to worry about the internal behavior of the system. And it has, kind of new more advanced operators to deal with streaming, such as support for event time, windowing, sessions, and transactional I/O to sinks. And also, structured streaming is designed to integrate into the rest of Apache Spark. So, for example, Spark can do interactive queries. And if we're doing streaming on Spark, why not let you do interactive queries on the state inside your stream? That's that application I talked about. You could just do it in this one system. So there's a memory sink that allows you to do ad hoc queries on the state. Spark can compute on static data. So using structured streaming, you can join against static data and against the results of batch jobs. And finally, Spark lets you add and remove queries at runtime, and it schedules them dynamically. So we support this in structured streaming as well. You can add queries, as your application evolves. So the kind of term we're putting out there, just because we want to give a name to this as opposed to streaming, is to say continuous application. So we mean an end-to-end application that takes in data in real time, but maybe does these additional things with it. Okay. How do you use structured streaming? It's actually pretty simple to use. Our idea there was to basically just incrementalize an existing query or computation using data frames or data sets. So you give us a computation in the data frame and data set API, whatever operators you want to use, and we just run the computation incrementally. As new data arrives, we update the result. So as a little simple example of this, here's a batch job that you might write using DataFrames. So this is a job that reads some JSON logs, say, from HDFS, and then computes a group by and writes it to Amazon S3. And notice that it's grouping by user ID and hour and stuff. And this is where, as you get late data and stuff, you might have to update some old results. So this is kind of an event time aggregation job. If you want to run this with structured streaming, the change is just this code in green there. So basically, instead of read, you do read stream, and instead of write, you do write stream. And then the computation inside is the same. The operators you're doing, the group by and average and stuff. And now you can run it incrementally as new data arrives. It will just update the result. And the guarantee it makes is that the result you get at the end in S3 is always the same as if you ran a batch job on a prefix of the data. So if you just stopped at a point in time and ran your batch job then, it would give you the same result. So this obviously simplifies things like debugging and testing and so on, because you know what you're going to get. Okay, and under the hood, structured streaming builds on the Catalyst optimizer that's in Spark, and basically it converts a batch processing plan into a continuous execution plan to run the query. So in this case, if we had the batch plan, which is to scan some files, aggregate, and then write to S3, for the streaming plan, we scan only the new files, we remember which ones we processed, then we do a stateful aggregate, so we have to remember the old state and update it for some keys, because there might be new events for those keys. And then we update S3 in just kind of the output files that were changed, or the output partitions that were changed if you're using something like Hive. And we output the new data. So that's basically how structured streaming works. And as I said, the end goal of this is we really want to build on Spark's kind of unique position as a kind of an integrated system that can do many types of big data processing. So the end goal is to actually let you build these full continuous applications inside one API. So if you have just a streaming system, you can certainly do a bunch of computation on it and write it to a sink. But with the same API, we want you to hook in stuff like ad hoc queries and get reliable ad hoc queries on, with some strong semantics about what data is in there. We want you to hook in static data. And if you have batch jobs or other applications built on Spark in your environment, we want to make sure that the results are consistent with them, and it's easy to develop kind of this whole pipeline. So that's what we're going for, in the future releases of it. And finally, structured streaming, as I said, is still an alpha component now, but it's one of the ones that's most actively being worked on. And there's a lot of stuff that has come out already since 2.0, and that will come out pretty soon. So in 2.01, we kind of put in the last pieces needed to support ETL workloads from file systems and Amazon S3. So that's kind of the initial use case that you can use the current system for. And it lets you load data and partition it and write it into something like Hive or Parquet in a reliable way, remembering which data you processed so far. In 2.02, some of the code that's been merged since then is basic Kafka input source and support for monitoring metrics. So this is stuff that will come out in the next release. And finally, in 2.1, some of the work that's in progress that will probably land in 2.1 is event time aggregation and watermarks, so improving kind of the state management. So this is still early on, but of course, we encourage you to try it out and give feedback, and this kind of feedback will improve the system long term. So we're excited to see what people do with it. Cool. So that's pretty much what I wanted to talk about. One final thing, since there are all these cool new features in Spark 2.0, we wanted to have a demo. And so I'm excited to introduce Greg Owen, a software engineer at Databricks, who's been preparing a demo of structured streaming as well as other new features in Spark 2.0.
All right, thank you, Matei. Bonjour Bruxelles, comment ça va? Don't worry, the rest of the talk will be in English. You won't have to deal with my terrible French. All right, so we all know how powerful Spark is, how incredibly simple the Apache Spark API is, and how easy it is to use Spark to extract value from your data. But this new structured streaming API in Spark 2.0 that Matei just introduced really takes Spark to the next level, because it makes it easier than ever to go from this kind of exploratory data science style analysis to an actual running continuous application in production. And that's what I want to demonstrate for you all today. So for this, we're going to use Databricks. And here you can see that I'm in the homepage of my Databricks workspace. We've got some example notebooks here. We've got some documentation down here. We also, elsewhere in the product, have just educational resources from several award-winning MOOCs that have been taught about big data and using Apache Spark. But for today, we're going to run our own notebook. So here I'm going to go to my home directory. And you can see that I've already got some sample notebooks here that are going to be, we're going to use these as helper notebooks in this demo. I'm going to create this notebook. Let's call it demo. And you can see that I've already attached it to this running cluster. We're going to be using Scala for this. And we're going to create it. All right, so normally when we do these kinds of demos in the United States, the subject that we focus on is the American presidential election. And I don't know if the news has gotten over here yet, but we are having an election right now. And a lot of people are very concerned about the way that it's going on both sides, and they've taken to Twitter to talk about it. And so there's a lot of data there. However, in order to save myself the embarrassment of discussing the political situation in my own country, I'm going to talk about something that's perhaps a little bit more relevant to people in this part of the world, and that's Brexit. So here, just to reaffirm this title, I'm going to go enter this markdown cell. We're now talking about Brexit. For the Americans in the audience, the UK just voted to leave the EU. There are many people on both sides of this issue who are very concerned with how it's going, and like with our election, they've taken to Twitter. And so we have a lot of data here from these tweets. And what we're going to do is, just as with sort of any typical workload, we're going to first try and extract some value from a small collection of representative data that we've collected offline, and then we're going to take that sort of workflow that we've developed and extend it to something more complicated, more production, using these new structured streaming APIs. And finally, at the end of this demonstration, we're going to use other APIs from Spark, including the Python API, to do some more advanced data science on this set of data. So let's first look at our data. What is it telling us? So what I'm going to do here is just show off, I have this collection of files that I've stored here in mount data tweets. And we're just going to get a list of these files so you can see that these are just completely unstructured. We have these like large parts here. And so I'm going to go in here and let's just look at one of these files. So we're going to just read from the top of this file. And what we're going to see is that this is just a collection of JSON blobs representing tweets. Here you can see we've got kind of like a created at field, text of the tweet, and some information about the user. But there's not a lot of structure here. It's going to be hard for us to really extract just from these raw files to do any real data analysis. And so the first step, as is so often the case, is we're going to just do a classic ETL. Let's go back to our markdown, and we're going to note that we're going to do some ETL from just these tweets to something a little bit more structured. Oh, yes. Thank you. All right. Hopefully, everybody can see this a little bit better now. All right. So what we're going to first do is we're going to use the new Spark Session API. This is new in 2.0. And what this is, it's our one-stop shop for interacting with Spark. In previous versions of Spark, we've had to juggle a Spark context, a SQL context, a query context, a Hive context, streaming context, all these different contexts. But now we just have this single point of entry for all things Spark. And so we're going to use this to read. And you can see that there are a variety of different formats that we can read our data from, but we know that our data is formatted in JSON, so we're going to read that. So just pass in the name of the folder, and we're going to assign this to a value tweets. And then let's just call display, so we can see what's actually happening here. And what this is doing, Spark is now going through and reading through all of those files, collating that data into one single collection, and then interpreting it as a data frame. This is an untyped data set. And here you can see that we've now recognized that we have these different columns. We have a created at column, the text column, those exact same things that we saw in the raw data itself, except now we've got it in a more structured format, and we can deal with it in a little better way. And there's some of this data that maybe we don't care so much about. Like maybe we don't really care about the user bio and user ID. So now we're going to progress and try stripping some of that out. And when I was looking at this data, trying to figure out what we do actually care about, I was reading through Twitter, and I noticed some common terms kept popping up. So let's just make a list of them here. We've got Brexit itself, of course, very much mentioned in tweets about Brexit. We had Theresa May. She's the Prime Minister of the UK. We had Boris Johnson, another influential UK politician. And then there was this other term that kept coming up that didn't seem to really fit with the others. And I was a little surprised by it, how frequently it was mentioned. And that's Marmite. So again, for my fellow Americans, Marmite is this salty yeast spread that the British people love to put on toast and eat for breakfast. I don't understand it either. But apparently, as a result of Brexit, the value of the pound has fallen relative to the euro to such a degree that it is now economically unviable for certain grocery stores to sell Marmite in the UK. And this has the British people up in arms. And so they've taken to Twitter to protest this. And so we're gonna look at these tweets as well. And so to get a sense of what we're actually going to do with these tweets, we can go back up here, go right back into our markdown, and we can just throw an image in here. And I prepared this image beforehand. /SSEU16-tweet. And what we're going to do here is we're going to take a tweet, much like this one from Time Magazine, and we're going to extract these particular terms that we care about from the tweet, label the tweet with those terms, and then finally examine when the tweet was tweeted and sort of bucket them into time windows based on that, so we can look at how the usage of these terms is changing over time. And now, one thing that you'll notice looking at this example tweet is that we have to be a little bit tricky about this, because it's possible that any individual tweet might contain more than one term. And so we're going to use some of the more advanced Spark SQL APIs to do this kind of operation, to explode out these multiple different terms for each individual tweet. So let's go down here. And what we're going to do is we're going to say tweets .select, and we're going to first window by time. So this is a built-in windowing function in Spark SQL. And we're going to window the created at field into buckets of 10 minutes. And then we're going to just call that the start of the tweet. We're going to also select the text of the tweet. And then now we need to figure out how we're going to extract this term. And fortunately, Spark makes it really easy to do this. We're just going to define a UDF. So val extract here is going to be a UDF, not an EDF. And what it's going to do is it's going to take the text of the tweet, which is a string. And then we're going to take the terms that we're looking for and filter based on does the text contain that term. And we're going to give ourselves a little bit of flexibility here, and we're going to cast it to lowercase so that we ignore just different cases. And so now what this extract function is going to do, I guess if you can see it there on the screen, we're going to take this text and then find only the terms that are mentioned in that tweet. And now in order to make this part of our ending data source here, we're going to just put this in and say explode, extract text, and we're going to call this a new column term. And then finally, we're going to cache this value as a table called tweets, which will allow us to access it via the SQL API. Oh, turns out I need to add a pluralization there. And so now what Spark is doing is it's going through that data set that we had above, and it's applying all these functions to it. And here we can see that we get our tweets finished. And so now let's just go directly into SQL. And describe tweets. And we can see that we've successfully extracted the start time, the text of the tweet, and this new term column. So now let's see what our data is actually telling us. We can do a little bit more advanced SQL here. And let's just say we're going to select count star. So we're going to take the number of tweets and the term and the start time. And then we're going to group by the term and the start and order by the same. So now I've just kicked off a Spark job to run this. And you can see that we get this table back. And this table, at first looking at it, isn't very intuitive how we're going to reason about what our data is actually telling us. Fortunately, Databricks makes it very easy to just go through, change the plot options here. We can group by the term and make it a stacked bar chart. And now we can see kind of how our data is changing over time. And there we can see our graph. And so we see that a lot of tweets are talking about Brexit. This is kind of understandable. If you're talking about one of these other things, you're also probably talking about Brexit. And we have a constant current of Boris and Teresa, and only a little bit of Marmite spread very thinly across these tweets. Except for this one 10-minute bucket. For some reason, that was a really good 10 minutes to be talking about Marmite. I don't know if maybe they had some big ad campaign then. But now let's take a deeper dive into our data and see what it's actually saying. So we can just select where the text looks like this. And so we can say, does this text contain, let's say, what happens if we look for NHS? We'll go through, and you can see that almost all of the tweets that reference the NHS are tagged with Theresa May. This makes sense. The National Health Service in the UK, Theresa May recently made an announcement about it. We can go back up and we can say, instead of the NHS, what happens if we're looking about article? You might expect a lot of Brexit tweets because of Article 50. And there are a lot of Brexit tweets you see here in orange, but we also see a lot of Boris tweets when we reference article. I wonder what that's about. I wonder if there's an article recently that came out about him. And then finally, what happens if we look for love? And we see that there are a reasonable number of Brexit tweets. I guess it is true that you either love it or hate it. But Marmite is really the clear winner here, just very overrepresented relative to the original sample. And we can see what the British people truly do care about. And so now what we've done is we've done this kind of exploratory analysis. We've looked at what our data contains. And we have some idea of what are the questions that we want to ask it. Now is the really cool part. Now we get to use those new structured streaming APIs that Matei just introduced to go directly from this sort of offline batch analysis to a running streaming application. And what I'm going to do first here is I'm going to start a stream. This is a replica of the Twitter Firehose. So now I'm just running another one of these sample helper notebooks that you saw also in my workspace. And you can see that we've defined this object tweet stream. And so let's look at what this actually is. This is the replica of the Twitter Firehose, by the way, that we're going to be dealing with. And from Spark's perspective, it just looks like a regular data frame. And this is exactly what Matei was talking about. We have the same exact API for interacting with the streaming data set or data frame as we do for interacting with the batch one. Except there's one difference. It knows that it's a streaming data frame. It knows that it'll constantly be getting more data, if it will tell me that. But once we have this data frame up and running, what we can do is we can take that exact same query that we ran up here and copy and paste it word for word and run it against this tweet stream instead of just tweets. All we have to do is change the source from the offline batch data frame to this new online streaming data frame, and Spark immediately understands that we're running a streaming job. And here you can see it's kicking off a whole bunch of different Spark jobs. As more data arrives, more jobs will be kicked off to incrementally compute the results of our query against this newly increased data set. And so we can go here and, again, do these same plot options. And we'll see that the plot just gets continually updated as more data arrives in real time. So this is pretty cool, right? This was just extremely easy to go from this batch process to the streaming context, to the streaming process. In fact, I have so much time left in my demo that I'm going to go do a little bit more. And what this really allows us to do is explore more deeply into our data. Now, instead of having to worry about getting from batch to streaming, we can get immediately to streaming and then go further. And so what I'm going to do is here, I've trained offline a classifier algorithm to do sentiment analysis on these tweets. And this is actually, if you are fond of data science, you've probably worked with Python. This happens to be trained in one of my favorite libraries, scikit-learn. And so we can see that even though we've been using Scala so far in the notebook, we can immediately dive right in and use Python directly in the same notebook by calling %Python. And we can just look at what this pipeline that we've defined is. And there it is. It's just a regular old scikit-learn pipeline that we're now going to use to analyze these tweets. And so let's see kind of what it does here. So if we say pipeline.predict, let's give it a couple sample tweets and see what it thinks is going to happen. So let's say, I think Brexit is a bad idea. What do you think it's going to have to say about this tweet? Versus, I love Marmite. It's delicious. And you can see that it classifies them differently. 1, in this case, is the classification for a negative tweet. 0, the classification for a positive tweet. So it recognizes that when we say that we love Marmite, we're generally being positive, and when we say that we think Brexit is a bad idea, we're generally being negative. And so now what we can do is we can take this and just directly, using that same Spark session object, register it as a UDF to use within Spark SQL. So we're going to call this UDF sentiment, and it's going to be a Lambda function that takes the text of a tweet and outputs the prediction from this pipeline. And because the pipeline takes an array and gives out an array, we have to do this kind of unboxing, and then we need to make it explicit that we're using an integer. All right, and now we've registered this function, and we can just go right back up to our still running streaming job, come back in here, and filter based on the sentiment analysis. So let's say that we select only the positive tweets. We're going to rerun this execution. And you can see that we've now updated to tweet stream 2. It recognizes that we're running a new query against the same data frame, kicking off those same new jobs as this data continues to stream in, except now we're doing the sentiment analysis on top, that we defined in Python, but are now running through this sort of Scala or SQL interface here. And we can see that now that we've filtered for only the positive tweets, our stream continues to update. We can see that there's still a reasonable number of Brexit tweets. Again, this reflects the fact that the twittering public is kind of divided on Brexit. And we have a little bit of Boris and Theresa, but once again, the clear winner of the British people's sentiment is Marmite, just way overrepresented here in the positive valence tweets relative to how it was in just the tweets at large. And so just to recap what we've done here in this demo. We started out with this idea that we had a whole bunch of tweets. We didn't quite know what we wanted to get out of them, but we had this sort of sample data set that we thought was representative of what our actual data might look like in production. Then we used Spark to load that into a data frame. We did some more analysis on it, structured it in a way that we were more comfortable with, did some time analysis, bucketing it into windows of 10 minutes, ran some batch queries to figure out what we actually wanted to get out of this data, and then we're immediately able to take those batch queries and run them against a streaming version of the same data, online in a continuous application. This freed us up with enough time to then use Spark's Python API to do more advanced data science, doing the sentiment analysis, and then which we could just very quickly register as a UDF and then bring right back into the SQL query. So now we've got basically an entire data science workflow, except we're missing the most important part. Because the critical aspect of data science is not just that we can make pretty graphs, it's that we can share this information with other people to affect how they make decisions. And so what I'm going to do now is I'm going to take this code that we've written, and I'm going to make a dashboard out of it. And now we can see, when we present this dashboard, that we've got all of the data and all of the analysis that we did here all in one nice, easy-to-view presentation, including a live updating version of that streaming graph. And now what I can do is I can share this dashboard with anybody inside my company, and they can use it to make actionable decisions in the future based off of this data that we've gathered. And this is the true promise of the new Spark 2.0 APIs. Thank you very much.